Hello, so I'd like to go over some applications of Venn diagrams. Now, most likely you've looked at how you can find the union of two events, so like A or B. Now, notice that the whole uh, set A and B is highlighted. So just recall that in order to look at a union of two events, the breakdown of that is that you have that A union B is the set of X such that X is in A, or you have that X is in B. Now, it is possible that A or X is in A and B, but let's go ahead and just look at it, in terms of the intersection. So we have, if we look at the intersection of the two events A or B, we have that that's going to be the set X such that X is in A and that X is in B. Now these two define essentially how the sets will be. So we have that this was our union, and this over here is our intersection. Now, whenever we look at Venn diagrams, we may actually look at, for instance, when we have that part of the set is not in it. So for example, if we want to look at the set A intersect B complement, well, this is actually going to be such that where we have that we're looking at all of the elements that are in A but not in B. Okay, so that's pretty tricky in how we're going to do this. So let's say that we have our event A, but let's say that we have our event B. Okay, so this is going to be event A, and this is going to be event B. But what this is telling me is that I want to look for all of the elements that are in A and all of the elements that are not in B. But an easy way to look at that is to look at the set A and just remove the part that's in B. So in this case, that would give you this portion right here. So what this tells me is that my set A intersect B complement is the set of X such that X is in A and that X is not in B. So we're just removing the part that's in B from our set. Well, if that's the case, then that means that maybe we can look at perhaps a different example where we have that we want to know what is the set gonna look like if I have A, and then let's say that we have the complement, and then we intersect this with B complement. So by definition, this is going to be the set such that we have the set X such that X is not in A and the set X that is not in B. Okay, now what this means is that we can find the Venn diagram that corresponds to this by doing the following. We have that all of A Okay, so we have all of A will be something like this, and then we have all of B will be something like that. So all of A, or the set A is right there, and the set B is right there. But note that you don't want the element to be in A, which means that it's outside of A. But we also don't want the set to have anything that's inside of B. So what that means is that the shaded region is everything outside of our set A and B. But if you look at it like that, there's another way that you can interpret this. So we have that all of this representation can be written as follows. We have that the complement of A intersect B complement is the same accordingly to the union of the two events, because we have that we're taking the complement of A union B, because you can see that everything outside of A or B is essentially its complement of the union. Okay, so in that case, we can actually look at another example when we have three diagrams or three sets. So let's say that we have a set A, and then let's say that we're going to union this with B, and we're going to say that this is going to be intersect with the complement of C. Now, normally we'll just use like primes, or we'll just use primes or little subscripts of C. So it's just either way that you want to see it. So we need to find the shaded region that corresponds to the union, or not the union, but the intersection of these two events. Now, note that if we draw our Venn diagram that corresponds to this situation, we have that that's going to be, okay, so we have that that's going to be our set A, and we have our set B, and we have our set C. Okay, so all that we need to do is just label this appropriately. So we have A, and then we have B, and then we have C. Now notice that what we want is that we want our elements to be in A or B, but not C. But if that's the case, then that means that essentially you have that the shaded region would be everything that's outside of C, but in A or B. So the way that I thought of this was that I just needed to look at the parentheses first. So that's going to be this whole portion. But I need to omit part of C. So the part that's C is this part right here. So let's just imagine that we're just going to sketch or shade in everything that's outside of our set C. And we just have this. And that's it. So we have that the portion of which that is the union of A or B but not in C is just this top half right there. Now I'll leave you with a type of application problem where we have that, say for example, at a college, there are 400 students taking finite math or statistics. Okay, now keep in mind that we don't know about any other thing than the people that are taking stats or finite. So what that means is that we can't really account for the whole universal set. So what we'll say is that there are 205 take finite math. And then we have that, let's see. So let's say that we have that 255 are taking statistics. And then we'll just say that 60 are taking both. So what we want to know is, for example, how many are taking statistics but not finite math. Okay, so essentially we have that we just need to figure out how many are just taking statistics but not finite. So notice that essentially we know how many people will take both of the two courses. So for instance, we know that A could be the number of finite math students. And then we know that B could be the number of stat students. So what that means is that we can actually just create a Venn diagram from this. So we'll just say that, for example, that we just go ahead and we draw our Venn diagram. Okay, now we have that we know about set A. We have that we also know about set B. So here we know that that there's a total of 205. So we're just going to do it like this. Let's say that we happen to know that 60 students take the class of finite and statistics, which is quite possible. But let's say that we want to know how many lie in the set A but not B. So 205 minus 60, that's going to be 145. So we have that there are a total of 145 students that just take finite alone. But that's not the question that we were trying to find. So 255 minus 60, that's going to be 195. So we have that, there's our answer. And note that, yeah, we don't actually know how many people are at this college, for instance. But if we did, then yeah, we would be able to figure out how many are not taking any of the two courses, which would be interesting if we knew that, but that's not what the question asked. So what that means is that the solution to this problem would be that there are 195 students that take statistics but not finite. Okay, so in that case, that finishes that question in terms of like how you would do that. Now you could have used a formula if you wanted to, but it's not really needed in this case. So, you know, you could have, yeah, used that the union of the two events is given by the count of A minus, not minus, but plus B minus the intersection. But note that the intersection, that's going to be a bit tricky because you're just trying to figure out, well, which one am I trying to subtract from? Because we knew that the intersection was 60, but we didn't know, yeah, like what was that portion that's only statistics students.